Hey everyone, I'm Khadija and today I will be analyzing global terrorism data from 1970 to 2017 by using Python in Google Colab. Did you know that during this period there were over 180,000 terrorist incidents worldwide? That means on average a terrorist attack occurred every single day for nearly 50 years. Terrorism doesn't just take lives, it shapes politics, disrupts economics and influences global security policies. In this video, we will use the Global Terrorism Database to perform EDA, which is exploratory data analysis, identify hot zones, study attack patterns, and finally derive actionable security insights. Now, let's begin by looking at our objectives. So, our goals are perform exploratory data analysis on the Global Terrorism Database, identify terrorism hotspots, and lastly, drives insight on attack methods, targets, and weapons that can guide security strategies. Now that we are clear on what we want to achieve, the next step is to understand the dataset we will be working with because good analysis always starts with knowing your data. In this step, I have loaded the global terrorism dataset and selected only the key variables that matter for our analysis, such as year, month, country, region, city, type of attack, target, weapon used, and number of people killed or wounded. To ensure accuracy, I handled missing values and created a new column for total casualties, which combines both killed and wounded, which gives us the total impact of each incident. Finally, I checked the time range of the dataset. As we can see, the data spans from 1970 up to 2017, covering nearly 5 decades of terrorist activity across the world. This gives us a long historical perspective of explored patterns and hotspots. Before diving into the results, let's quickly ask, why do exploratory data analysis at all? So, EDA basically helps us summarize large data set, detect hidden patterns, and spot anomalies. It turns raw data into meaningful insight, which is especially critical here because terrorism data is complex with thousands of incidents spread across decades and regions. Without EDA, these patterns will remain hidden, and when it comes to terrorism, hidden patterns can mean missed warnings. With it, we can highlight trends, identify hotspots, and provide actionable recommendations. Let's start by looking at how terrorism has changed over time. To visualize these trends, I grouped the data by year and plotted both the number of incidents and total casualties. Looking at the yearly trend, terrorism incidents were relatively lower but persistent from the 1970s through the 1990s. Then we notice a sharp rise after 2000 with incidents peaking dramatically after 2010. The year 2014 stands out the deadliest with the higher number of attacks worldwide. Casualties follows a similar trajectory with noticeable spikes in the 2000s and peak again around 2014. These graphs make it clear that terrorism has become more organized, more aggressive, and far deadlier in recent decades. Now, let's move from time to geography and identify the global horizons of terrorism. To do this, first I grouped the dataset by region and counted the number of incidents. Then I plotted them to see which areas stand out the most. When we look at regions, the result shows that the Middle East and North Africa, South Asia, South America, and Sub-Saharan Africa are the most affected regions. Together, these regions account for the majority of global incidents, highlighting the need for stronger international cooperation and intelligence sharing among nations in these zones. Next, at the country level, Iraq, Afghanistan, Pakistan, India, and Nigeria dominate the list. Iraq in particular towers over the rest, reflecting the long years of conflict and insurgency there. Finally, then we zoom into cities. Baghdad, Karachi, Lima, and Mosul are the worst hit. Up here at the top, Baghdad alone has experienced thousands of terrorist attacks, making it the most heavily targeted city in the world. Here, also notice a large category called unknown. This reflects incomplete reporting in the dataset. Still, even with these missing values, the real hotspots are very clear. Bar charts give us number, but a world map helps us to see the bigger picture. By plotting attacks as a chronopath heat map, we can visualize terrorism intensity across countries over the entire period. The darker the shade of red, the higher the number of incidents. With the location mapped out, let's now turn to how these attacks were actually carried out. By studying the tactics and method used, we gain insights into both the operational patterns of terrorist group and the vulnerabilities they exploit. To explore this, I grouped the data and counted the number of incidents for each category. Then I plotted the result as a bar chart to see which methods dominates globally. Here, as you can see, bombing and explosion dominates the landscape, followed by armed assaults and assassinations. This indicates that terrorists rely heavily on methods that can cause mass destruction in crowded areas. Next, let's by looking at the target types reveals the private citizen, military, police, and government institutions are the most frequently attacked. This mix reflects both symbolic attacks on authority and indiscriminate violence against the general population. Finally, looking at weapon types, it shows that explosives are by far the most common followed by firearms. The dominance of explosive highlight how easy access to low-cost materials can be turned into devastating attacks. Taken together, these graphs paint a clear picture that how terrorism relies on cheap but highly destructive tactics, with civilians often bearing the greatest burden. Next, let's evaluate how effective and deadly these attacks are. To do this, I calculated three key metrics for each region, which are success rate, suicide share, and average casualties. The percentage of attacks that were successful is suicide rate. The proportion of attacks that were suicide attacks are suicide shares. Average casualties is the average number of people killed or wounded per attacks. The analysis reveals a critical insight. While suicide attacks are fewer in number, they are significantly more lethal than other types of attack. The data showed that average casualties are highest in regions with a high share of suicide attacks, particularly in South Asia, Middle East, and North Africa. This highlights a major security concern. A small number of these high-impact attacks are responsible for a large share of the overall casualties. Let's dive deeper into these metrics by looking at them individually, starting with the success rate of attack across different regions. As you can see on this bar chart, which I generated from our metrics data frame, it shows that percentage of successful terrorist attack in each region. The results are quite revealing. As you can see, the data reveals a surprise fact that Central America and Caribbean have the highest success rate from the terrorist attacks, with a 90% of attacks being successful. In contrast, other highly affected regions like the Middle East and South Asia have slightly lower rates, which can indicate more active counterterrorism efforts. The data tell us that security and defense strategies must be region specific. In areas with high success rate, there is a greater need for proactive measures like enhanced intelligence gathering, improve on the ground security, and better inter-agency cooperation to disrupt attacks before they can be executed. The number clearly show where these efforts are more regularly and urgently needed. Now, let's look at truly critical metric. The share of suicide attack by region. The pie chart gives us a different perspective. As you can see, the two largest slices of the pie belong to the Middle East and North Africa and South Asia. This shows that even though suicide attacks are not the most common type of attack globally, they constitute a significantly large proportion of terrorism activity in these specific regions. This is a powerful insight when combined with our earlier findings that suicide attacks are the most lethal. It tells us that not only are the most affected regions facing the highest number of attacks, but they are also home to the deadliest attack strategy. This makes understanding and preventing these types of attacks top priority for security efforts in these areas. Here, Let's look at the average number of casualties per attack by region. This matrix is a powerful way to understand the sheer lethality of terrorism in different parts of the world. Looking at this bar chart, you can immediately see a stark difference between regions. The Middle East and North Africa and South Asia stand out with the highest average casualties per attack. This finding reinforces for what we saw with suicide attack data. These regions are not only frequent targets but attacks are also on average far deadlier. This final bar chart is perhaps the most important visual in our analysis. It brings together our previous two metrics, suicide share and average casualties, to reveal a powerful correlation. Here, this final bar chart brings together our previous two metrics, suicide share and average casualties, to reveal a powerful correlation. As you can see, the tallest blue bars representing suicide share are in the same regions that have the tallest orange bars representing average casualties. Specifically, look at the Middle East and North Africa and South Asia. This visual evidence confirms our hypothesis. Suicide attacks, though not the most common, are by far the most lethal. They are responsible for a disproportionately high number of deaths and injuries. For security analytics, this insight is a game changer. It means that to reduce casualties, we need to focus on strategies that specifically prevent or disrupt suicide attacks, as this one tactics is the most significant driver of the terrorist attacks lethality. So, what does all this data mean for keeping people safe? So, firstly, we learned that we need to focus our effort on hot zones like Iraq, Afghanistan, and India and Pakistan because that's where most of the attacks happen. Second, we need to make our public places safer. Things like stores, buses, and train stations, what we call soft targets, are attacked most often. So, we need to protect them better. Third, because most attacks use bombs, we need to get better at finding and stopping explosives. This is a key step to prevent mass casualties. Finally, we found that suicide attacks are the deadliest, even though there are not as many, they cause the most deaths. This means we need to create special plans and use smart strategies to stop them. Just remember that this data has a few limits. It only goes up to 2017, so it doesn't show what's happened since. Also, some countries might not report attacks as well as others, and a lot of attacks were done by unknown groups, which makes it harder to track them.